Hello and welcome. I figured this would give you a nice smile because you could see how pristine, since we're talking about air pollution, how pristine that atmosphere is right there. And maybe you're watching this when it's raining out, when it's cloudy out, maybe it's not so nice out there. So hopefully this brings a nice smile to your face and you enjoy that beautiful view there right in front of you. So without further ado, let's change the view. I feel so very bad for you because now this becomes your view. Hey guys, what's up? And welcome back to PHS Science with the Fabs. That's me, the Fabs. So let's continue on. We're gonna do a little work here. We are gonna cover some PowerPoint slides and we are gonna have a good time doing it. All right, everybody. So without further ado, let's all bring you up to speed. We will be covering slides 13 through, give me 1 second here. We'll be covering slides 13 all the way through slide 28 today. Yes, I know it's a long one. There's some videos in there. I will be sure to link those up at the end and point to them all cool and be like, yo, they're right here, they're right there. Just so you guys can't see me, they're like right there, right there. They're somewhere around. So, you know, be ready for that. So without further ado, let's get started on this because this is going to be a little bit of a long one today. And I appreciate you guys all sticking with me and watching this. And yeah, so without further ado, let's talk about those major air pollutants. So some of the major air pollutants that we're looking at are carbon oxides. Now this can be carbon dioxide, carbon monoxide, right? Carbon monoxide, for example, CO, is a highly toxic gas that forms during the incomplete combustion of carbon-containing materials. So when we don't have a complete burn, we're lacking oxygen. So there's not enough oxygen to completely combust the fuel. Because there's not enough oxygen, you're not getting that O2, the CO2, you're just getting CO because there's not enough oxygen to go around. It is colorless and odorless. You know this, right? We have CO detectors in your home by any open flames, your furnaces, your hot water heaters. It can kill you, okay? Indoors, make sure you have the CO detector. If you still have a furnace or wood, coal, stove, anything that completes combustion will emit carbon monoxide, okay? Just to let you know that, just to let you know that. So moving on, I don't know why I repeated that, but excuse me, moving on. So is CO2 a pollutant? Well, it's a very good question. Think about this. I just breathed out, right? I breathed out. I just took a breath out. I take a breath in. I just exhaled a breath. Now, my God, it's thunder and lightning out. Pretty scary. So I just took a breath. I exhaled a breath. What came out in that breath? CO2. You're very correct. So is it a pollutant if we expel it, if organisms expel it, if green vegetation takes it in during photosynthesis? Is it a pollutant? Well, in the pre-industrial revolution, we had around 270 parts per million in the atmosphere. Today, we are up around 390, an increase of 120 parts per million. 93% of the CO in the troposphere occurs as a result of the carbon cycle. That's cool, right? That is carbon that was there. It's in our carbon cycle. It's being traveled around from atmosphere to ocean to land to living organisms, so on and so on. That's cool. However, there is some that is not part of the carbon cycle. There is some that was anthropogenically produced through industry, the burning of fossil fuels, carbon that was at a time dormant. All right. CO2 is a major greenhouse gas. It does indeed trap and re-radiate energy back to Earth's surface. 7% of the CO2 in the troposphere is anthropogenically made, meaning mostly burning of fossil fuels. It's like I just said that. Oh, wait, I did. You're looking at that equation right there. That is the combustion equation where we take a hydrocarbon, combust it with oxygen, and it produces water and CO2. It is not a regulated pollutant. Excuse me. It is not a regulated pollutant. Okay. Sorry, guys. I had a wicked, awesome cauliflower burger today. Very good, very tasty. And oh, some sweet potato. Oh man, I will tell you, it was wonderful. But anyway, back to pollutants. It's not regulated. all right? Because remember, we expel it. Organisms expel it. When something breaks down, it releases carbon dioxide. Okay, so you have to be very careful when we're talking about this as a pollutant. If it's coming from an anthropogenic source, totally. But if we're releasing it, is it a pollutant? How do you put a gauge or a monitor on something that we're breathing out? It's very tricky. So think about that. Continuing to move on, we see the atmospheric CO2 graph. As the years progress, CO2 is on the rise. It is going right on up. So how would you vote? Question: should carbon dioxide be regulated as an air pollutant? Maybe you say no, right? Because funds are limited. They should be spent on regulating and reducing more toxic air pollutants, such as mercury, lead, the heavy metals, right? Maybe you say yes. Carbon dioxide is a serious greenhouse gas, and its emissions must be regulated and reduced. Good idea. Are we talking anthropogenic? Are we talking naturally occurring? What say you, O wise student? What say you? Seriously, I should go into acting. I mean, not to toot my own horn, but toot. I should be an actor. So let's keep moving. Nitrous oxides. So we talked about the carbon oxides. Now we're going to talk about the NOx, the NOx's, the nitrous oxides, produced from nitrogen and oxygen in high temp combustion reactions. Most emissions are from burning fossil fuels. Remember the cars, the diesel, the coal, the natural gas, the petroleum. Some are from soil bacteria and are fixed from lightning strikes. Now, again, we think about the carbon dioxide and how some is naturally occurring and some is anthropogenic. Same idea here. Now, dinitrogen oxide, N2O, is a greenhouse gas, and we get that from the combination of atmospheric nitrogen and atmospheric oxygen, or diatomic nitrogen and diatomic oxygen combining to produce two NOs, nitrogen monoxide, and from here, two nitrogen monoxide compounds combine with a diatomic or atmospheric oxygen to produce two nitrogen dioxides. Okay, that is our NOx gas. This is a reddish brown gas that is a main component in photochemical smog. Now, photochemical smog is NO2 is a precursor to ground level ozone, which is very dangerous. It's not the same as the ozone layer up there in the stratosphere. This is ground level ozone. The ozone in the stratosphere is a good thing. It's important. It's needed. The ozone that occurs at ground level is not a good thing. It is deadly. It's a deadly gas. It's O3. It is no bueno. Okay, not good. NO2 plus H2O yields nitric acid, and I've explained to you before that nitric acid, sulfuric acid, carbonic acid are all of those gases that occur in acid deposition or acid rain. So something important to remember. Acid rain or nitric acid is a respiratory aggravant. It aggravates your respiratory system. Can increase the likelihood of bronchitis, asthma, irritation in the eyes. So just a little fun fact about nitrous oxides. Moving on, let's talk about those sulfur oxides, those socks. The Red Sox, you say, in baseball? No. The White Sox in baseball? No. The dirty socks on your bedroom floor that really should be washed? No. These are sulfur oxides, SOXs. Now, they again, just like carbon oxides, just like nitrogen oxides, they again are naturally occurring as well as man-made or anthropogenic. They can come from volcanoes, evaporation of sea spray, or they can also come from coal burning power plants, oil purification, industry. 2/3 come from human sources, come from mostly combustion reactions, sulfur combining with diatomic oxygen, sulfur-containing coal. When we talk about clean coal, we're talking about, so when everybody says, oh, it's clean coal, what that means is it is low sulfur-containing coal. The reason we want to look for low sulfur-containing coal is to reduce the amount of sulfur oxides that sulfur dioxide that we're putting into the atmosphere. Sulfur dioxide combines with oxygen, elemental oxygen, to produce SO3. SO3 now combines with water to produce sulfuric acid, H2SO4. And this again occurs in acid rain or acid deposition. Okay, SO4 ions are droplets. They are bad. They can get in your lungs. They can cause irritation. It is bad. All right. So talked about the carbon oxides. We talked about the nitrogen oxides. We talked about the sulfur oxides. What is next, you ask? Well, let's find out. Oopsies. Let's find out. Suspended particulate matter, or SPMs. All right. These are actually little particles of matter that are in air. So think about when you burn your fireplace, when you combust a piece of wood, right? You let smoke into the air. That is particulate matter. Solid or liquid particles suspended in air, or aerosols, right? Soot, lead, asbestos, sea salt, sulfuric acid, pollen, spores, ash, dust. So scary. It reduces visibility by scattering light absorption. And it's the smaller the particle, the more harmful to humans. Why is that? Because it could make its way into your respiratory system all that much more easier. In through your nose, in through your eyes, in through your ears, in through your mouth. Yeah, that's pretty much about it. So fine particles are anything less that are less than 10 microns, ultrafine less than 2.5 microns. These can get into your lungs, cause bronchitis, asthma, allergies, aggravate your asthma. Diseases, what if they're viral or bacteria? They could lead to death. According to the EPA, or the Environmental Protection Agency, suspended particulate matter is responsible for about 60,000 premature deaths each year in the US. Okay, how about that to think about? Man, we are moving quite along. You guys are doing excellent. I'm all very impressed. Let's continue the fun train with urban outdoor air pollution. So industrial smog is a mixture of sulfur dioxide droplets of sulfuric acid and a variety of suspended particulate matter, mostly emitted by burning coal in those coal power plants. Now, in the developed countries where coal and heavy oil is burned, industrial smog is not a problem due to reasonably good pollution control. However, this is not necessarily occurring in the developing countries. The pollution control is not very good there. So as a result, you get more photochemical smog that presents itself. We're going to get into exactly what photochemical smog is, or industrial smog. So it results from coal and oil burning. It's the killer London fog. You can actually see this fog rolling in and then rolling out. It's crazy. In 1952, killer London fog killed roughly 4,000 people. We're talking about particulates of carbon, SOx, and carbon oxides. Okay, we're talking about carbon combining with diatomic oxygen to produce carbon monoxide and carbon dioxide. Unburned carbon, like the soot, the particulate matter, that's creating your sulfuric acid and your nitric acid. And this creates a brown ammonium sulfate. It stinks, it's nasty, it gets into your lungs, you breathe it. Ew. It's still a problem in developing countries, again, because of the lack of pollution control that is enforced. Okay, so hopefully I'm keeping your attention by making this entertaining, but this is a serious problem, and this does need to be given its due cause and its due diligence. So photochemical smog, what exactly is it? Well, as you can see from that diagram below, photochemical smog has a brownish tinge to it, a brownish color. Okay, how is it caused? Cars, bakeries, dry cleaners, anything that emits particulate matter into the air. It's a brownish orange haze. You need sunlight. See, the weird thing about photochemical smog is sunlight activates it. You could have all the chemicals present, but until you have sunlight, you don't have photochemical smog. But once that sunlight starts to activate the NOx gases, the VOCs, the volatile organic compounds, then you get the panaldehydes, the nitric acid, the ground level ozone, and that is your photochemical smog. The O3 is ozone, the panaldehydes are the peroxyl nitrates, the nitric acid. The hotter the day, the more intense sunlight, the more smog, the worse it is. And it peaks in late morning and early afternoon, and that is because the sun is at its most intense. Right? Think about it. It's like the warmest part of the day, right? The clearest part of the day when the sun's rays can hit you. There's the sun. Where are we? There's the sun, right? And it's shining down. Not really a fan of this iced tea with peach, but hey, you get what you get and you don't get upset. All right, continuing to move on, we're looking at sunlight plus cars equals photochemical smog. As I said before, you need that photochemical, you need the sunlight to create the photochemical smog. Okay, it's a mixture of air pollutants formed by a reaction of nitrogen oxides and volatile organic compounds, VOCs. I will link this video up at the end of the PowerPoint, excuse me, at the end of the video so that you guys can watch this. Moving on, sunlight plus cars equals photochemical smog. Again, we've talked about Mexico City, or excuse me, we will talk about Mexico City in the next video, how it's considered to be a bowl. It has mountains on both sides, and it's essentially a valley. And the bad thing about this is the air is stuck there. It's trapped there. And as a result, photochemical smog forms. Many cities, Mexico City is one of many cities in sunny, warm, and dry climates with many motor vehicles that suffer from an influx in photochemical smog. And you can see it right from the diagram there. It does have that, that hazy, that brownish color, and it pretty much engulfs just the entire city. Moving on, guys, we're almost done. I'm so impressed with you guys staying with me. You're doing an excellent job. We're still talking about the outdoor air pollution. Outdoor air pollution can be reduced by settling out. So basically you allow the particulate matter to settle out, to fall to the ground. If you're in chemistry, you want to like have it precipitate out to the ground. Sea sprays, winds, and chemical reactions. Outdoor air pollution can be increased by urban buildings. Okay, anything that stops or inhibits wind flow. Wind flow will carry the pollutants out. However, if you lack that wind, it's not going to move the pollutants. Mountains, it's slowing wind. It promotes temperature inversions, high temperatures. Remember, the higher the temperature, the more intense sunlight, the worse the photochemical smog is. Moving on, ozone. We've seen ozone before. That's O, three O's together, O, O, and O. It's good in the stratosphere. In the ozone layer, it's wonderful. It's there. We need it. It's great. It's our friend. However, in the troposphere, it's bad. Ground level, you don't want it. It helps to create, it is a byproduct. It is photochemical smog. Smog plus O3, smog will give you O3, ground level ozone, the panaldehydes, and other oxidants. And oxidants are very dangerous to your respiratory systems. Right. Moving on, we are almost there, guys. Just 2 more slides, and that is it for the day. Major air pollutants, volatile organic compounds. We've talked about this, and you've seen the VOCs. Well, what exactly are they? Most are hydrocarbons emitted by leaves of plants, and methane. Methane. We say it methane, but I've heard it pronounced as methane. About 2/3 of global methane emissions comes from human sources. Some VOCs are emitted as unburned gasoline fumes, and other VOCs include industrial solvents such as trichloroethylene, TCE, benzene, as well as vinyl chlorides. Okay, and these are very dangerous chemicals as well. And then our last slide, guys, here it is. Give yourselves a round of applause. You've made it to the end. Those hydrocarbons, VOCs. Plants, they're a major source, and that's cool. That's fine. Okay, there are naturally occurring compounds and chemicals. That's just part of it, and that's good. It's the man-made ones, the anthropogenic ones that are harmful because they are being pumped into the atmosphere at such high rates that our natural systems cannot keep up with them. The VOCs, the isoprenes, the benzenes, the formaldehyde, the vinyl chlorides, the chloroform, the unburned gasoline, it's all a component of photochemical smog. Okay, respiratory health can cause cancer. Long exposure to VOCs, to benzene, can cause cancer, blood disorder, and immune system damages. Now, please understand that many of these pollutants do occur naturally in our atmosphere, and that is cool, like I said before, because our systems can keep up with that. However, it is the man-made portion, it is the anthropogenic releases of these chemicals that make it very difficult for our systems to absorb. Okay, they are overloading our atmosphere, and that's where we get our air pollution from. I hope you've all enjoyed this video, this notes video. please, I would ask you to watch the video that I will link up right here. Wait, oh my God. It was in front of my face. Do you believe that? Well, guys, have a great day. Please watch this video, and I will see you all in the next video. Take care, everybody. Bye-bye.